Number 9. Solve the equation by expressing each side as a power of the same base and then equating exponents. So here in number 9, we have 4 to the 7 minus 3x power equals 1/16. And the directions say express each side as a power of the same base. Since we had a base of 4 on the left, we need a base of 4 on the right. 1/16 is 1/4 squared. That's 4 to the negative 2. So we rewrite. We keep the 4 to the 7 minus 3x power, but now on the right we have 4 to the negative 2 power. The directions said then equate exponents. When we have two sides written as the same base, that means the exponents must be equal to each other. So 7 minus 3x must equal negative 2. Solve this for x. Subtract 7 from both sides. Negative 3x equals negative 9. Then divide both sides by negative 3. Negative 9 divided by negative 3 is positive 3. X equals positive 3. Number 10. Solve the logarithmic equation. Be sure to reject any value that is not in the domain of the original logarithmic expressions. Give the exact answer. We have log base 2 of x equals 5. We can get rid of logs with exponentials. A log base 2 has an inverse function of 2 to the x. So if we raise both sides as powers of 2, 2 to the log base 2 of x equals 2 to the 5th. The log and the base 2 cancel each other out, just leaving us with x. So we would have x equals 2 to the 5th. And 2 to the 5th is 32. You also could have thought of this another way. Remember, a logarithm is an exponent. A logarithm is an exponent. So base 2 exponent 5 gives us what? 2 to the 5th gives us 32. So you could have thought of it that way as well. We move into systems of equations now. Number 11 says solve this system by the addition method. The addition method, or the elimination method as it's also known. This is given to us nicely for the addition method because we have a plus y on the top and a minus y on the bottom. And if we add straight down, then x plus x is 2x. Y plus negative y cancels away. Negative 8 plus 14 is 6. So we add the two equations together and we get 2x equals 6, which means x equals 3. Now plug that back in. I plugged it into the top. 3 plus y equals negative 8. We need to do that to solve for y. 3 plus y equals negative 8. Subtract 3 from both sides. We get y is negative 11. So the solution to the system is just the point 3, negative 11. X of 3, y of negative 11. Number 12, solve the problem. One number is 1 less than a second number. Twice the second number is 14 more than 5 times the first. Find the two numbers. So here, let's let x be the first number and y be the second number. That would mean that x is 1 less than y. X is y minus 1. That's our first equation. And then we would have twice y is 14 more than 5 times x. Twice y is 14 more than 5 times x. 2y equals 5x plus 14. Since one of our equations is nicely in the form x equals, we can use the substitution method to solve this system. X is y minus 1, so plug y minus 1 in for x in the second equation. That gives us 2y equals 5 times y minus 1 plus 14. The y minus 1 is in parentheses because the entire 5 is multiplied by the entire x. So distributing the 5, we get 5y minus 5. Bring down our plus 14. Negative 5 plus 14 is positive 9, so we have 2y equals 5y plus 9. Subtract the 5y over to the other side so that we have y's on the left and numbers on the right. 2y minus 5y is negative 3y, so we have negative 3y equals 9. Divide both sides by negative 3, and we get y equals negative 3. We still need our x. So take negative 3 and plug it in to that first equation that had x equals. X equals y minus 1. That would be negative 3 minus 1, which would be 4. So x is negative 4. Again, I think I said 4, but negative 3 minus 1 is negative 4, just to make sure that I said that correctly. A little behind the scenes peek for you. I am filming the exam 3 solutions right after filming the exam 2 solutions, right after filming the exam 1 solutions. So I've been at this for some time at this point. Things are starting to blur together on the screen for me. But our x was negative 4, our y was negative 3, so our two numbers are negative 4 and negative 3. Number 13. We want to solve the system of equations x plus 4y plus 5z equals negative 23, 4y plus 3z equals negative 20, and z equals negative 4. This one is easy if you start from the bottom. We're given that z equals negative 4. We can plug that right into the second equation and be able to solve for y. So z equals negative 4. That means 3 times z is 3 times negative 4, or negative 12. That makes our second equation 4y minus 12 equals negative 20. Add 12 to both sides, giving us 4y equals negative 8. Divide both sides by 4, giving us y equals negative 2. Now we have z and we have y. We can plug both of those into the first equation and solve for x. Y was negative 2, so 4y is 4 times negative 2, which is negative 8. Z was negative 4, so 5z is 5 times negative 4, which is negative 20. That makes this x minus 8 minus 20 equals negative 23. Negative 8 minus 20 is negative 28, so x minus 28 is negative 23. And then add 28 to both sides. Negative 3 plus 28 is positive 5. So x is 5, y is negative 2, z is negative 4. Our answer is the ordered triple, 5, negative 2, negative 4. X, Y, Z. Number 14 says solve the system by the substitution method. So there's no way to do elimination here. because they aren't both linear. This is a nonlinear system because we have this x squared plus y squared equals 13. And if we think all the way back to unit 1, x squared plus y squared equals r squared is the form of a circle centered at the origin. So that first equation is a circle centered at the origin with a radius of radical 13, somewhere between 3 and 4. So you can visualize this. This is a line, x minus y equals 1, crossing through a circle, meaning we're going to have 2 points where these intersect. Solutions to systems are points of intersection. So we want to make sure we get 2 answers here. The easiest of these 2 equations to solve for a certain variable is going to be the second one, the one where they're not squared. X minus y equals 1, we can add the y over to the right, giving us x equals y plus 1. We then need to substitute that into the first equation, and that's where things get tricky because we're squaring the variables. We're squaring the x. We're squaring the 1 plus y. 1 plus y squared is 1 plus y times 1 plus y. That's going to give us 1 plus 2y plus y squared. Plus the y squared again that was already there equals 13. Combine like terms, y squared plus y squared is 2y squared. Then we have our plus 2y plus 1 equals 13. Get everything on one side and 0 on the other. Subtract 13 from the right over to the left. Positive 1 minus 13 is negative 12. So we have 2y squared plus 2y minus 12 equals 0. We can divide both sides by 2. We can divide everything by 2 here. And that gives us y squared plus y minus 6 equals 0. We then attempt to factor. We need numbers that multiply to negative 6 and add to positive 1. Multiplying to negative 6 and adding to 1, those would be positive 3 and negative 2. So this factors. Y plus 3 times y minus 2 equals 0. Using the zero product property, y plus 3 equals 0 implies y equals negative 3. Y minus 2 equals 0 implies y equals 2. So we did get 2 answers for y equals negative 3 and y equals 2. We now need to find the corresponding x value to both. And remember, x equals 1 plus y. So x equals 1 plus y would be 1 plus negative 3, which would be 1 minus 3, which would be negative 2 for the x that goes with the y of negative 3. So one of our solutions is the point negative 2, negative 3. Then we have our y of 2. X equals 1 plus y, so x equals 1 plus 2, so x equals 3. The x equals 3 goes with the y equals 2. So our second point is 3, 2. Our answer overall, negative 2, negative 3, and 3, 2. Finally, number 15. Graph the solution set of the system of inequalities or indicate that the system has no solution. We have 4x minus y is less than or equal to 4. And we have x plus 3y is greater than or equal to 6. We're going to graph each inequality separately. They're both or equal to, so they're both solid lines, not dashed lines. Let's imagine that instead of an inequality, we had just an equation, 4x minus y equals 4. Well, we graphed these things way back in Unit 1. 4x minus y equals 4. We would look for the x-intercept first. That's where y is 0. If we plug 0 in for y, that gives us 4x equals 4, which means x equals 1. So the top inequality has the point 1, 0. Let's look for the y-intercept. That's when x is 0. If x is 0 in the top, that first term goes away, leaving us with negative y equals 4. If negative y equals 4, then y equals negative 4. So 0, negative 4 is a point on the top inequality. So let's graph that line that we get from the top inequality. A point at 1, 0, which would be right here. A point at 0, negative 4, which would be down here. So this line right here, we get from the top inequality. Whoops. There we go. We need to know what side of that line, the left or the right, we're shading on. Let's plug in the point 0, 0 into the inequality. Plugging in 0, 0 gives us 0 is less than or equal to 4. That's true. So the side with 0, 0 is the side we shade. So we can imagine shading everything to the left of this line. The solution overall of this system is going to be where the shadings overlap. Now let's do the same stuff with the bottom inequality. Let's find the x-intercept. That's where y is 0. Imagining that that was an equation instead of an inequality, the 3 times 0 would go away, just leaving us with x equals 6. So that was relatively simple. X equals 6, y equals 0. We plot the point 6, 0 right there. Looking for the y-intercept, that's where x equals 0. X equals 0 makes that term go away. That just leaves us with 3y equals 6. Divide both sides by 3. We get y equals 2. So 0, 2 is the y-intercept. We plot that point right there, and we draw the line between those 2 points. So this line here, we get from the bottom inequality. Let's check 0, 0 again to find out what side we're shading on. If we plug in 0, 0, we get 0 is greater than or equal to 6. That is false. So we don't shade the side with 0, 0, we shade the other side. We don't shade the bottom, we shade the top. So we imagine all of the top is shaded. So all of the top is shaded. All of the left is shaded. That's going to overlap in the top left. So this region, just the top left, where the 2 sets of shading is overlapped, is our solution. And that's exam 3.